Thanks for everyone for joining me. This is it's honor. I'm honored to be here, and this is it's a great day to learn more about Node and JavaScript. Did everyone have a good lunch? Great lunch. Good music. Lots of. Only in Nashville, right? So I do have a web page up where you can get the slides and the code if you want later, or now, whatever. And so it's up there at codewins.com. That's NC 2015 for November conference. They just abbreviated that. And of course my Twitter and GitHub is Jeff Bieske or Codewins, and my email is jeff@codewins. All right, so I thought I'd start with a little XKCD. So, who of you have ever typed in sudo something and then it says this incident will be reported? So, and then he says, well, who does these incidents report to? So then, the last slide there shows. So you got to be good. I had a boss that. One time sometimes we'd be checking connections at work, he would, on somebody else's laptop, he would type in an inappropriate address, and it's like, this guy's going to get called by HR, I mean, it's not good, you can't do that kind of stuff. So one more fun one here. So more sudo jokes. All right, so my name is Jeff Barczewski. Again, thanks for being here. So I'm a owner and instructor at Codewins, and I'm currently working on a React Fundamentals online training course. I hope to have that out in a couple weeks. And previously, I was an aerospace engineer in the Air Force. I had a lot of other jobs, RGA, Elsevier, and then most recently, before Codewins, I was on the MasterCard team. And I worked on a small project called Apple Pay, which was fun. And there again is my email and that. So feel free to reach out to me later if you get questions. So I guess to make the most of this, who here has heard of microservices? I mean, it's a buzzword, so probably most people. Who has heard of microservices but would like to actually know what they are, what that means? Okay, I had the same feeling. Who wants to learn more about pros and cons for microservices? When to use them, when not to use them? And then who wants to see code? Okay, all right. So what I have 4 main parts. I'll go briefly through microservices since you kind of know what they are, but I'll just touch on that a little bit. We'll go into benefits and risks. We'll do some strategy on how to apply them and when to apply them, and then I got some code to go through. So a few years ago, I worked at a company that had this large web app, and it was your typical web app. You have JavaScript, server-side rendered code. This was written in Java. This was Struts 1.0. This was early Java. This was before all of the good stuff started coming. And it was this large piece of code, created with classes and object-oriented programming and all that, but it was just one. It was actually 2 big pieces, but both those pieces were huge. And it was hard to do anything with it. It was hard to upgrade. It was hard to, there was very minimal tests, so we were scared to change it. There was limited documentation, so only the people that worked on stuff knew what it did. The knowledge, the people, it was real siloed knowledge as far as, what people knew about. And just creating new features was slow. It took, it was really hard. We had forks of this code for different clients, so clients needed certain tweaks, and so then you'd fork this, and you quickly know how quickly that gets out of hand, when you're trying to manage that. To scale it up, you had to put a new server up. It was a whole thing or nothing. So there was no way to scale it up other than that. And then, there's just defects and stuff. This stuff was complicated. There was a lot of ways that things interacted, and so we had problems. So anybody else had this kind of an issue at some point, anywhere in your career? Yeah. So what can we do about that, or what do we learn from history? So one of the quick things, that we've always go back to is the Unix philosophy: do one thing, do it well. So small programs that do, they're easy to get your hands around, your head around. They pipe things in, one thing to the other. Then SOA came along, so service-oriented architecture. And but it usually used like this big ESB, used SOAP. So it was moderately successful. I mean, some places did better with it than others, but it was still pretty complicated. So it didn't seem like it was the end all. REST comes along and really kind of shows the way forward, with simplicity. So that's a step forward. But then things start to change. We've got now billions of users out there with all these iPhones and Android devices. Netflix with the set-top devices. So now you've got users all over the place. Things are being pushed real time. The web is starting to be used for transactions much more than previously, where it was browsing documents. So now it's small fetches and small transactions. So we've seen people, companies like Netflix and Facebook move towards stuff like Relay and Falcor to try and address some of those things, because REST was too large-grained. It didn't quite go there far enough. So microservices kind of evolved out of all of those things. Some people called it fine-grained SOA. It was smaller in that, but I think the SOA term was so tainted that that didn't stick very well. Another person called it replaceable component architecture. But then in around 2011, 2012, some of the people, the architects that were gathering at some of these meetings, were kind of trying to come up with a term, and microservices seemed like the best term that kind of emerged out of all those discussions. So it kind of stuck. However, there's not really an official definition of what it is. It's everybody's got an opinion. For me, the main thing is it's a style of architecture where you're using smaller, focused processes that do one thing well, kind of like the Unix philosophy, but they're communicating over lightweight means. So you're not communicating over an ESB that's got a lot of logic in it. So it could be HTTP, it could be messaging, those kinds of things where it's real lightweight and dumb, and it just puts it in a queue or whatever. So the benefits of something like this, of microservices, is that you can spin these things up independently. You can assign different teams to these things so they can work at their own schedule. They can deploy new versions as they need to. They don't have to wait and to coordinate with all the rest of the group to upgrade. You can replace things out. So one day, if you decide you want to put a new version or you want to redo the thing in a new language or whatever, it's encapsulated. It can be replaced. It can be upgraded. Elastic and scalable things are easy to go down or up. So if you're not stuck with doing the whole server again, you can do, I can just deploy another instance of this thing, maybe even on the same box, so to take advantage of more CPUs, or more memory. You can use different programming languages, so that's a nice thing if there's a certain type of task that really needs a particular thing. So you've got some image crunching that you need to do, and you've got this C library that does it really well. You could use that for your image processing, while the rest of your stack is written in whatever. So that's kind of a nice thing. So it could be Node or Java or Ruby or whatever. And you can also use whatever databases you need. In fact, that's kind of a recommended practice, is to have your own database and your own tables and that. And it could be shared on the same system, or it could be a whole different system that you're managing. But the ability for you to quickly change things as you need for that team, for that microservice, independently of other people, that lets you get those quick developing time. However, caution with the whole different languages, because not everybody on the team might know how to do Go or Rust or whatever language it is. So you're gonna isolate people to where they can help out. So, and the advantage of being managed by different teams. It can enable resiliency because things are set up that way to call out to something, so we can make things very robust. So if a particular system goes down, we don't have to fail the whole thing. We can keep going. So if your Facebook page is running, but you don't have a list of your most recent likes or whatever, some piece of the app that's you could still do other things. That's possibly a valid thing to do, to continue on, to let the user continue to do some things until this thing comes back up or whatever thing gets fixed. But that does take a little bit of preparation to do that. These things are composable. You can cache them, you can combine them, you can aggregate, so that's nice. It does allow, because they're broken out by a message boundary of some sort, allows monitoring and tuning, so you can really watch things and check. You could do some of these things in your other apps as well, but it's just a lot easier when it's a separate process to be able to do this and to watch how much CPU it uses, how much memory it uses. So that's a lot harder to do when it's all mixed together in a monolith. So it's all great, right? I mean, there's no downsides to this kind of stuff. Well, there's risks. So you don't want to start moving to this too quickly if you don't know what the domain you're getting into. So you might want to start with a monolith as you're trying to learn your system and how things work and how things are where you can draw these boundaries, because otherwise if you quickly put this into a microservice too soon, then every time you need to make a change, you might have to make changes in both places if you didn't get things right. You might be stepping on each other a lot. And you don't want to get into versioning too quickly. I mean, it's going to probably happen at some point, so you got to plan for it. But you don't want to be bumping versions every day. That's not going to be fun. Siloed knowledge. So if we do have different technology, you got to make sure you got a team that's going to be able to manage it. So that's important. Rapid change versus quality. Because these things are smaller and focused, teams will be able to move faster. They might have a tendency to overlook things like documentation or testing or those kinds of things, so you need to be aware of that. Need to do due diligence. Deploying and logging complexity. So sometimes we're going to want to be able to do lots of these microservices, and you don't want to keep having to manually add new things to your deploy scripts or to your to manage logs separately for each thing. So you want to have some kind of automated way or some kind of system that you're using that you can basically take advantage of these things, and that kind of worry goes away. And then version compatibility. You might want to have one or more versions. So if it's a forward compatible change, you can probably just get away with upgrading the system. But if there's a breaking change, you might want to keep the old version around until your other consumers upgrade or until for some point in time. So does it work? Well, I didn't get to try this out on that monolith. I left there before that happened, but I did use it on this kind of technology on other projects, and it worked really well. It really allowed us to scale up and to tune how much memory and how much CPUs we're using for different things. And I'll actually even give, in some of the code I'm talking about, I'll kind of give you some more ideas there. Here's some more stories so Netflix, I think you might have known that in March there was a web story that said they serve 37% of the web bandwidth at peak time. So 1/3 of more than that is just Netflix, one company is serving that much bandwidth. 1 billion API calls a day, six microservice calls per API call on average. Amazon's a website, 100 to 150 web microservice calls per web page is what the documentation says. And then eBay is split over 75. They split their microservices over business areas so that their teams can. It ends up being a lot of times how you have your team structured, in your company can be a great way to break things up for the microservices. It just works out pretty nicely in that way. So that's what they ended up doing. So most people are pretty optimistic about microservices. It's really things work. There are risks, but you can manage them. It does seem to become the default way for building enterprise apps. there's just so many good things that come along with doing it this way that you know, the risk can be managed, and it's just it seems like it's the future, at least, you know, the best thing we can come up with right now. So how do we do this? Well, you want to evolve this thing. You want to start slowly. You want to do, you know, one microservice here, one microservice there. You don't want to jump and immediately go to, you know, 100 microservices, because that's just going to be a mess. You know, you kind of grow into this, learn how to do things, get your automation down for these things. That'll make it easier for the next one. You know, you want to take advantage of resilient design. You want to think about allowing the systems to stay up if the piece goes down. You know, do we really have to fail the whole thing if this one system goes down? A lot of times that can be true. And plan for scalability. How do we add more services? How do we also, those people that are managing those microservices, you don't want to have one guy or two guys that you know it and then they leave. So scalability is also about who else can take it over if they need to, or fix it. So, all right, so let's get into some code. I'm going to mention first that, you know, to start to move towards microservices, the first step is to start to functionalize things. So move things out of maybe that OOP into more functional style, calling functions, put those functions in separate files. Eventually those might go into separate repositories. You're starting to move things separate. And if you can live with these things separate and they're not conflicting, you're not jumping back and forth too much, then that might be a good fit for a microservice at some point. So you can kind of start to move that way, and you still get a lot of advantages of you know, limiting what people have to worry about. When these functions are limited to a file, you know, this is all I have to look at. You know, I don't really have to consider, you know, all these other things. It's a pure function, the inputs and outputs. So let's get into let's look at some code. All right, so you've got some asynchronous things you want to do with your system. So let's say we've got this expensive thing like sending mail. You know, that takes time. It's something you don't want to do on your main thread. You know, it takes a while. Sometimes it has to be retried. So let's say we want to do a microservice to send mail. The one thing that we chose at the company I worked at was to use Redis. We actually tried RabbitMQ, had some issues with that, and we were going to be adding Redis to the stack, and we said, well, let's try Redis as a queue, and that was just, it was beautiful. The Redis was just, it's solid, it's fast, it's easier. I mean, I don't know if the problems with Rabbit was due to user error or configuration. Probably could have been, I don't know, but Redis was just simpler. And what makes it good is that it has these different structures. It's not just a cache like people use it. You know, a lot of people use it for. It has structures like lists that you can queue things up. And specifically, you can push and pop things on. It's an atomic transaction, and it also has a blocking pop. So that means that when you're listening to it, only one client will get the result. So then one microservice can take advantage of that. So that's kind of the idea here. We've got a mail client. So oh, that's pretty light, isn't it? I guess I'll just try to talk through it. There's I'm pulling in IO Redis as one of the newer Redis libraries, and I've got the key I'm using in Redis is called MailQ. And oh, and just before I move too much further, let me start up Redis, and I'm basically starting it up with append fsync always. So you can turn it on to persist the transactions at a scalable amount, and so it can be if you don't need persistence, you can turn that off, or you can tweak it to once a second or whatever. But I'm doing it at the slowest possible thing, but it's also the most durable. And so just doing the benchmark for this on my laptop here, it's getting 500,000 requests per second for get requests. So that's usually pretty good, you know, and that's on a single CPU. So if you want more than that, you can run more of them. And even for pushes, it gets 156,000. Now this was slower because it's syncing to the disk every transaction, but it's still 156,000 requests per second. So pretty awesome. So mail queue was my list in Redis that I'm going to use, and I'm basically I've set up a pipeline, so I'm basically taking advantage of the driver ability to pipeline things, and I basically call L push. So I'm calling a left push, pushing this onto the left side, and I can push whatever I want. I'm just going to stringify like the object that I have. So in this case, I have a message body, and let's see what that looks like. Okay, so I queued 10 things, and then in Redis, type. In Redis, I can list out what's in the memory right now for that list, and you can see the different structures. They just are stringified objects. So I can push whatever I want into the queue. I basically called exec down here to run everything was in the pipeline, and then I quit when I'm done. So that's queuing it up. Now, so now let's go over and look at the server, and it's just about as simple. So we've got the IO Redis. So this is a separate process. It's going to be started up on its own. It's going to look at mail queue, and then it's going to do this blocking pop. And so we basically are blocking. We're going to go ahead and listen for the first thing, and we're actually doing it's a write pop, BR pop, so the R stands for write. So we're going to take it's a first in, first out type queue if you do it this way, and we're going to just go ahead and wait. And if it has something, it'll immediately return, and it'll give me the object. The second command, or the second parameter, was forever 0, so I'm not going to time out. I could pass the timeout, and basically this thing will just wait. And then as soon as it gets something, it'll immediately call the callback. And so this is kind of the nice thing that how this makes it easy to do these services. You can just sit here and wait, no fancy logic. And then as soon as you handle the sending of the message, just put this back on, put the process next tick, call this back on the stack again, and it'll keep listening. So this thing just keeps waiting for messages. And then when you're ready to shut down, I'm just going to call Redis disconnect. I do have to, instead of calling quit, I call disconnect because it's listening to this blocking pop. So if I don't call disconnect, it's going to sit there and wait. Quit will nicely wait. It won't force you to get out. Where disconnect says, no, you got to go home. You got to go now. And so anyway, so if we quickly run, wrong one, but. So if we run the service, I guess I gotta type right. All right. Let's go ahead and queue some more messages up since I already. Okay, so they instantly, as soon as they're put in there, it'll instantly fire. Let me put in lots of messages, and so now you see it. Fire more often, and then again scaling this thing up. I can start to have as many of these things as I want, and I can dynamically fire these things up or shut them down. And they're getting different. Only one of these services is getting each the message, so it's only getting delivered once, and Redis is managing all that. So, and that's all the code there was, and you could wrap this up in a function and keep this behind the scenes and not have to worry about it. Now one thing I'll point out is this is the simplest version, but if you pop this off the queue and you didn't deliver it, if you actually crashed, then that for some things that might be bad. You want to make sure that you didn't lose it. So you can do a little bit more work. With a reliable service, what I call a reliable service, and it's just like the other one, except I'm going to do two lists. So I've got a mail queue list, and I've got a mail in transit list, and then I do a blocking write pop L push. So this is an atomic transaction. As soon as it gets, just like the other one, but it'll also now take that, it gives it back to you, but it also sticks it in the new list. And then later on down here, when I send the mail, I can actually remove it from that list. And if for some reason I don't remove it, then it will, I can have another process come in and like say, oh, you need to requeue that. So you basically can reliably manage, making sure nothing happens and nothing goes wrong. The next thing, I'm going to just briefly show it, and I'll go right into the Hapi stuff because I wanted to mention some Hapi stuff too. The next code I was going to talk about is we had a need to, we had expensive operations that at this one company. That could be something like, image processing, could be crypto, could be calculating which ads need to be displayed, looking up, all of the factors on what ads to display. Maybe your server can't keep up with that kind of load, so you want to pre-do that operation and pre-cache this in a list. So we did this with, this is my fictitious ad cache generator, so it's also a list. And what this does is I basically check the length of the list, and then if it's below a certain level, then I start generating. I start putting more things on the queue, so then something else is going to pop these off when it's ready to use them. And so this is just as simple as doing an L push and generating, and when it gets to a level, stopping, and all that. And so it's real nice because then you can, and this can, you can still make this thing work so that if it doesn't have something to cache, you can still go ahead and do the processing, but you're not stuck. So this is kind of nice too. You can really speed up some things or that. So that's with the cache. Let me jump over to Hapi since I'm running slow on time. All right, so with Hapi, I've got, it's so easy to make microservices with Hapi. So, right here I've got a server route get, and I've got a handler, and I'm basically replying with, with an object, and that's it. I mean, I do a connection up here, and then I have a quit down here, so, and it's got all the other stuff you need. It's got all the, the other components and things that you normally would have, so that makes it easy. Let's see if you wanted to, let me jump over to my main example. Okay, so with Hapi, you can easily turn this thing into, so now you can do microservice pretty easily with Hapi or Express, whatever. The next thing would be like a gateway. So you want to put this smart gateway in with your microservice, and it might be able to redirect to different things. It might be a smart load balancer. It might do, check authentication first before it routes. There's a lot of things you can do. You can do A/B testing. And so one way to do that is with this H2O2 plugin that comes with Hapi. And so I'm basically just registering that, server.register. And then down here, I've got a get for friends, recent, and prefs. And I'm basically passing it to this same proxy handler. And I'm basically looking up in the proxy map what I should send it to. So I can basically send this there, this here, that there, and that makes it real easy to manage. And beyond that, so that's, that makes it real easy to do these these proxies. But what if you wanted to create a service that, for a mobile device that you didn't want them making 3 requests, 1 request for three different things? This is, Walmart needed this for a lot of their stuff. So again, using another plugin, Rec, is Hapi. It's just like request. You could use request as well. And I'm basically, for this request called main, I'm actually going to do 3 gets. So I'm actually going to call out to friends, recent, and prefs, get all those things back, and then once I've got all that data back, then go ahead and respond back to the client. And that's all the code there is, to do that. And I've actually, you could also use an async library or something like that, but I just did it here with a callback. And let me just fire that up, and then we'll get on to the final wrap up here. These 30 minutes sessions go fast. Okay. All right. Okay, so this was the main request, and it was pulling the data from all 3 of those things. All right, so wrapping up. Going beyond, there's a session 245 with Wyatt Proul talking about Seneca. That's a great framework that can go beyond these ideas and take it further and allow you to use a lot of different things for your transport besides just Redis, or it does do Redis and HTTP, but you can also do more things. Kafka is a very high throughput messaging, durable message store like Rabbit, but more powerful, and it can do lots of interesting things, and it's clusterable. Very, very nice. Stream services, Amazon has a Lambda service, so you can run functions on stuff automatically without even have servers, and it just charges you per transaction, and so you can scale up instantly. Kubernetes is in a Google project to do microservice scaling with Docker containers, and it can basically run for you, put whatever you configure and keep those things running and scale them up as you need. So it can, as load goes up and down, it can adjust things. So great stuff. This is where the resources and slides, and I don't know if I have any time for questions, but I guess I'll be out back and I can answer them there. So.